Welcome to Mavens of Data. This week we're speaking with Doug Needham, author of The Enrichment Game and Data Structure Synthesis. My favorite part was hearing Doug share all about data enrichment and its role in enhancing data usability and accessibility. I hope you enjoy this episode. Doug, I am so happy to have you here. Thank you for joining us, and thank you everyone who's listening for joining us as well. For those who may not know you or haven't yet read your books, could you just give us a quick background about what you've been up to?
Yes, sure. So I have been working with data. It seems like every time I go into an organization, I usually immediately start making data better, making it better able to be used, make it easier to be used, etc. And so I started getting called the data guy. So I just kind of embraced it. So Doug the data guy. That's my email and whatnot. I started out my career as a function DBA. I kind of moved through that and became a data architect, and then ultimately become a data scientist, working with. So it's all making sure the database is available, organizing the data, then finally using the data. So I've been all over the place using data throughout my career. A lot of my stuff early on was supporting application developers with being a DBA, supporting that. And as time goes on, you have the situation where, hey, we have this other data, we need to combine it, we need to do other things with the application data. The application, they've got their priorities, they've got their things going on, whatever. That's fine. Well, so where do we? Well, let's go talk to the data guy. So, okay, import this, do things with it, and then combine it with the application data, and let's see what we've got. Okay, cool. Here you go. Give it to some kind of statistical person, some data scientist, before the term data scientist became a thing.
Yeah.
And then they would go magic with it. And it's like, oh, okay, cool. This is really important. Great. All I did was load data, and then you did some stuff with it. But, so through my career of doing a lot of stuff with data operations, doing things with data operations before it became data ops, organizing data, all of that kind of stuff, I always wanted to figure out what is the best way to do this, right? What is the best way to organize things? So a lot of study, a lot of reading, and the results are these two books, The Enrichment Game, which talks about enriching data, and the Data Structure Synthesis is a little bit more of it's a little bit more tech heavy in that it explains some of the mathematics behind why these data structures, using these data structures this way, why it works that way, and then also how you can save some money too. So.
Yep. Which is very often the focus of all the businesses you're going to be working with.
Absolutely.
Perfect. So if we're talking about those two topics, data enrichment and data structure synthesis, I think it would be helpful if we started with some, maybe broader definitions. So
Absolutely.
could you, start with maybe what data structure synthesis is and how is it applied?
Okay, so one of the things, the way that I think of, I struggled with coming up with a name for the book because as I'm writing all of this stuff down, and I was going into a lot of math and a lot of this other stuff, I'm like, I don't want it to be just another math book. I want it to be a story. So it ended up being more of my story, and so as I'm writing things, I'm talking about my story, starting out in the Marines and doing this and doing that, and doing the other thing, and how you're bringing these things together, and it was all, oh wait, I'm bringing things together from multiple sources. That's synthesis. I'm synthesizing the data. I'm using all of this stuff together. And so that's where I came up with the term data structure synthesis. And in some ways, for anyone that is familiar with things like dimensional modeling, data vault modeling, any of the even DW 2.0, some of the writings of Bill Inman, if you look at some of the things that they've done, a lot of it is build something once, use it multiple times. And so you're as you bring in new stuff, you're figuring out ways to fit into this bigger puzzle, right? And so as you're putting these things together, you're synthesizing the new thing with the old thing. Old, 2 weeks ago, right? You're synthesizing all this together and making. And so that's kind of where I came up with the term data structure synthesis. Is just build something once, Use it for multiple things. Too often I've seen things just built for one purpose and then throw away. Well, in the data world, you don't really throw data away. And that becomes a problem for people like me because, like, if I don't know what a set of data engineers are doing for whatever reason, and I'm responsible for the overall operations of the data environment, and you've got these data structures out there, and I don't know what they are. Okay, are they used anymore? So I have to do all this heavy lifting to figure out are any queries even hitting that table? Okay, there's one query every 90 days that hits that table. I'm dropping that table. That's gone. Yes. I need to go. It's gonna somebody will come back. Okay, that's really what you need. All right, now let's run something properly and use it as part of this overall thing. You don't need that structure. You need this structure over here, which could be a couple of. So basically, it's just building something, reusing it, and then growing it and making it more and more valuable as time goes on.
Right, and making sure that it's set up to scale as you add more data. Right. Okay.
Absolutely.
So, yeah, and then so give us an overview of what data enrichment is. I've personally only used it when we're buying third-party data for, we might get demographics and maybe other supplemental data that's, things people might be interested in or stuff that came from different credit cards or something. So, what organizations do you see data enrichment used in? What is the bigger view of what data enrichment is? What areas does it touch and how do people use it?
Well, I'm one of those bold enough that I think because my definition of enrichment is data that was not originally part of the application that ensured some data. So let's say you have an accounting system. Okay, so what's an off-the-shelf one like NetSuite? Okay, NetSuite is going to do something that is associated with NetSuite, right? And if you ever want to tie that account information with some other, a homegrown application that is selling a product or what have you, you're going to have to bring that. You're going to have to bring that stuff together. So you're going to be enriching this NetSuite data with your homegrown application or some other stuff, even for marketing. Demographics is another thing. The Bureau of Labor and Statistics, they've got some amazing information out there. One of my earliest experiences with third-party data was wanting to do some reporting and analytics using a third-party hierarchy system for SKUs. So SKUs, I forget what SKU stands for. You may know. I don't remember at the time because I'm not really doing a lot of stuff with retail today. But SKUs have a hierarchy, right? There's a certain hierarchy, certain types of products, organic food, whatever, right? And one of the things that at the time, the data warehouse that I was working with, they needed some of their products broken down by this third-party system. Well, there was no integration. So I had to go get all this SKU data, put it in a hierarchy, and then tie that back to our data internally. So almost anything that you're doing where you're working with, I'll use the term some industry standard. Whatever industry you are in, there is going to be some industry standard for a breakdown of products, hierarchies, something like that. And these standards bodies are going to produce, in my experience, has been like an Excel spreadsheet. They've got this Excel spreadsheet. Everybody works on this, and they're like, okay, this is version 1 of the standard. Everybody does this. And so some business analyst internally is like, okay, we want to break our data down by this. Well, where's that in the application? It's not in the application because that's not the hierarchy we use internally for our reasons. We've got good reasons for doing things different. So you have to do this mapping. You have to go through this whole. There's a business project associated with this where, okay, I've got the technical data. I've got a subject matter expert over here, subject matter expert over here. Bring them into a room, put on boxing gloves, and everybody has to fight over.
Yeah.
But then you organize it and you come up with, okay, so we're enriching the original data with this third-party thing, bringing it together. This is how we're going to organize it, and then you make that into a repeatable process. So that whole idea of just what you described of I've got to bring in this third-party data. It's nothing to do with our internal applications. It's nothing to do with our accounting system. It's nothing to do with blah 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 whatever. Okay, well, at that point, by definition, you're enriching,
Hmm.
and however you want to do that. Sometimes you have to do that for regulatory requirements, what have you. But there's a need for it,
Yep.
and that is a data ops team. That is a data ops team that's going to do that. It's not an application development team. Too many priorities. Their backlogs filled for months. They're not going to have any priorities for doing that. So us data people come along like, oh, all you need to do is combine this. Cool. Let's create some data structures. Let's make sure it's organized, repeatable processes, all of those kinds of things. Six Sigma, CMM, all of that kind of stuff that we do, and make it to where it's just we just load data and there you go. Now you got new reporting. Off you go.
Yeah, no. And you mentioned that there's a need for it. There absolutely is. And I feel like
Mhm.
even when I've had a need for it and pitched for it, I don't always necessarily get it. But at the same time, when I was studying data, most of the data sets gave you sort of those demographics. And then you could speak to who these people were, and you could start to infer maybe how their behaviors might be different. We don't want to infer too much, but you understand that they're different people. And then you get into industry and all of a sudden you have click data, you have, data about transactions, but it doesn't tell you anything about, what these customers actually look like. And so it's so different when you get access to data and all of a sudden, because you're like, I found that my stakeholders were confused too. Have you, what have you seen as the appetite for companies to invest in third-party data to enrich their analysis and be able to get those more demographic views of their customers?
It has entirely depended. There have been, believe it or not, I know I'm a old fat ugly guy. I've actually worked with some fashion firms,
Ooh.
and there's been a couple of different organizations I worked with, and like, they're not really high fashion. They're associated with high fashion, and I don't want to name them, but you can see them in my LinkedIn profile, and I'm not hiding anything. I'm just not advertising for them. But some of the things that they needed to do, the target market was young ladies.
Mhm.
Okay, so is this a young woman? Is this her parent? And then so certain products were geared towards younger women. Some of the products were geared towards middle-aged ladies, and so they had two totally different product lines, and it ended up being multiple companies that were supporting these things. Well, the demographics, as you're describing, that becomes important because as you're doing a transaction, if you're dealing with a transaction, a woman comes in to purchase these particular things, and I'm saying women on purpose because it was all women that were buying these things. A lady comes in to buy something, and all you have is that credit card. Well, okay, so we have that. Maybe we have name, address, and address and whatnot. Some of the basic information. Well, then you can go to basically taking that. You go to bureaus and such. Say, okay, this is the person that bought this. Can we get more demographic detail? Um, and so you can bring that in. Another organization that I was with, they were specifically targeting um, females that were of the type that had joined sororities. Okay, that's a tiny demographic, right? Very specific, and they had very specific needs because they were getting certain dresses and uh, things associated with the sororities. Okay, I was never in a sorority. The fraternity that I was in,
Really?
you can see. I'll give my little tattoo there. I was in I was in the Marines, so I wasn't even that was my fraternity. They have certain needs, and so okay, cool. So there's certain things associated with that, and one of the interesting things were certain times of uh, early in the season they may need a particular type of dress. Later in the season they would need a different type of dress. All of that was not associated with the application. That was just like a calendar, right? So this is this third part is the third party thing. The reality, a calendar. We know beginning of the semester they may want this. End of the semester they may want this. And oh, by the way, we've also got all these accessories to sell. So there's another opportunity for us to make money. So let's make sure that we have these types of accessories that are available for this type of. So all of that stuff was not within the application. While bringing all of this data together, enriching that original application data, enriching the product information, and then making it available internally for decision makers that were figuring out what are they going to do from inventory, how are they going to forecast this, all of these things. So funny enough, fashion just is the thing that comes to mind when it comes to enrichment, just because there was so much of this third-party information that was not part of the application specifically. And it became a really big deal. Actually, the third-party data ultimately was bigger than the application.
Wow. And so you mentioned that you were in the Marines and showed us your tattoo. I know you have a really interesting story about updating data virtually during Desert Storm, which we all know was a very long time ago. And so, I'm sure other data nerds would find that very interesting as well. Would you mind sharing that with us?
I hope they find it interesting. So some of the stuff that we did. So this is in the 90s, and what we did, and I talk about this in detail. We created a virtual mainframe, and what we did is we would work in this virtual environment, and there was a lot of stuff going on. I was one of the junior guys on the project, so I ended up doing a lot of the heavy lifting and carrying things around. But we created a virtual mainframe. We did all the stuff. We set everything up. We went into where we went to another location where we actually built out a mainframe on the back of a truck. This was, I think, the 3390 series class mainframe. We deployed everything in that truck, made sure everything was up and working, and then we sent it to the Saudi Arabia theater. I was working remotely. Some of the other team actually deployed into Saudi Arabia. And essentially, ultimately, what happened is the team in theater, they did a backup of the data. They restored it. There was a few tricks to it onto the thing that we built, and there was no loss of data. So this was 90s. It was a virtual environment. We had no project managers involved. There was no Jira. Believe it or not, I was actually working before Jira came along. There was no Agile. There was none of this other stuff. It was literally just make this work, guys. And by the way, your brothers are depending. That was the overarching thing. Let's get this done. These are the steps that we need to do. By the way, they're sequential. We need to do these things. Can't do this until this is done. So we need to build this. Let's get it done. And we built it, and there was zero data loss through the entire process.
No, I mean, I find that wild because in the 90s, right, it wasn't until the later 90s that I even had access to use AOL through a modem. And so, yeah, and it sounds like a really high stakes environment, and
Absolutely.
just that I didn't even know was possible. So what do you like, are there any learnings that you got from that or other parts over your earlier career that you think apply to somebody who's working with data right now?
So the number one thing, I could tell stories.
I love
I'll try to
stories.
keep it short. One of the overarching things that I learned being a DBA in the Marines is data represents people. You can never forget that. If you do, you start to there's a mental shift there. I can tell when people are talking about it. It's like you don't realize what you're looking at is actually representing people. So when as I transitioned on, got out of the Marines and did some other stuff, and I'm working with different things, you can see, like I was talking about for fashion, I knew that the data represented these women's choices, right? I've known, for some of the other applications that I've supported, like the other thing with merchandising, those were consumers in a particular market that were buying food, right? I knew what was going on, right? So, okay, yeah, we had, three there. Okay, what does that three represent? Is that three these things, or is it people? How many? Whatever. So the number one thing that I have never forgotten from my early lessons learned was data represents people, and that was almost literally beat into me by someone, because it's like, remember the things that you're supporting. This is your brother Marine, sister Marines, their payroll, their healthcare, all of these other things. So if these systems go down, you're going to have a bunch of people that are mad at you, and they know how to shoot. You don't want to disappoint them. You're right. Okay, yeah, I get it. So it's never, after I got out, it was never been quite that drastic anymore. But nevertheless, data represents people. Whatever the interaction is, somehow there is a person involved on the other end of the screen. And you may not think about that person. You may not, they may not, that you may never meet that person. Chances are you never will. But one of the things you need to realize, humans are doing stuff. And part of what we're doing as we're collecting and managing the data is the data that we manage represent this human interaction somehow, whether that be them giving us money, whether it be us paying them, whatever. That's the number one thing. The other thing, and this is a little bit more on the technical side, years later, I was working with something. I was working at an organization, and we were bringing in, this was all on-prem, so pre-cloud. We were building out of SAN. And so I was, I was just a DBA, just managing these things. And, we had these SAN engineers come in and they were doing stuff. And so they were like, oh, well, you don't need to be involved in setting up the SAN. You don't know anything about it because you just databases. Okay, fine, whatever. We ran into some difficulty when it came to performance. And so they were like, okay, you need to go talk to the SAN engineer. And he's like, okay, what's your background? And I said, well, I was in the Marines. I built mainframes. I did this. And, oh, you have a mainframe background. Then you know what this is. It explained to me how the SAN works. I'm like, yeah, this data storage. I did the Marines. I did that 15 years ago. And he's like, yeah, okay. So this is, I'm like, oh, okay, this is what you need to do. And I actually told the guy how to fix it. And I'd never seen a SAN. And for those of you that don't know what a SAN is, it's a stored attached network. And basically, it's a bunch of disks that are available to remotely rather than physically attaching it to a device, to a machine. And again, for those that are in the cloud world, a machine is something like your laptop, only a little bit bigger, that does processing. It's somebody else's computer. That's what the cloud is.
Yep.
I'm being a little snarky. There's a lot of really interesting things that I learned working on mainframes that now in the cloud environment, it's like, oh, okay, that's very similar to what I did, by the way, 30 years ago. Yeah, I get it. So it's just a different, using some new technology, obviously. But conceptually, it's very similar to what I already did.
And so how do you, like, if you were designing that, how do you approach designing systems that can handle the, fast changing data, needs to be dynamic? Like, how do you think about approaching setting something like that up?
So one of the things that I think is I go back to first principles, and first principles for me is some of the writings of like Chris Date, John Giles, Dan Lindstedt, those kinds of stuff. Some people may think of them as theoretical, and that's fine. But understanding that they were writing to solve a problem, right? So chances are the problem that I'm facing, I'm not the first person ever to face it. And that is to me the height of hubris that I see. People are like, oh, I don't want to. Why should I go read any? Why should I go study other architectures? I'm just going to build this from scratch. Well, by studying, you're going to get to some of these lessons learned by things that have happened. And yes, it's not the same thing. There is a bit of new. You got to figure out a way to apply technologies to get it. But it is, it is totally the height of hubris. First person ever. Chances are you're not. And you just have to understand what those that have gone before have done. What were they trying to solve? And then you're like, oh, okay, so this is similar to these things. Okay, so if I follow the principles that they follow, then I need to do something a little different than what they did. But in principle, conceptually, they're very similar. And when you do those kinds of things, you're able to, you kind of humble yourself a little bit. You learn a decent amount. And then chances are you're going to produce something better because, as Newton has said, you're standing on the shoulders of giants. And as soon as you take the hubristic approach of I'm the first one to ever do this, you're not leveraging anything else. It's you against the world. Sometimes you're right. Chances are, the probabilities are you're not. And you need to learn some lessons. And the lessons that have been learned by the people are important, because as we do that, as we apply them, we're going to build better things.
And so when you're setting up these systems, do you have any lessons to share about managing performance and cost? Like, how do you think about it, and what do you look for when trying to balance the number of different things that you're trying to balance when setting up a system?
So again, I'll go back to first principles, and I wrote about some of this in data structure synthesis. I actually have some mathematical tools that explain how to make things a little bit more cost efficient, and why doing it this way saves money. Those first principles are very important, and there are times, I'm not saying you always have to do exactly that, but understanding the rules and the quote unquote rules, I should say, and your use case makes you better able to make adjustments to break the rules, quote unquote.
Yep.
I had a design session with another architect. We were doing a lot of stuff with dimensional modeling, and we read Kimball's books and attended some webinars, and we were all very familiar with his designs and such. And we came across a situation, and I can't remember the specifics of it, but it's like, wait, none of the stuff that he talks about is going to work here. And so we actually designed something that was slightly different. And that's one of the things that I said was, well, we're kind of off-roading a little bit here, but the nice thing about it is, because we understand all those principles, because we know why he's done some of the things that he's written about, we know this is going to work because it doesn't fit into all of these other things. Right? So we had, and I forget what it was, but I'll just use this as an analogy. Let's say Kimball wrote about 3 different categories of things. Well, we had a 4th situation, and it didn't fit into any of these. But because it didn't fit into any, we'd already eliminated things from his writing. We knew that this was going to be something that we had to do because we had that knowledge. We had that theoretical knowledge as well as the practical application. So understanding a little bit more of why some of these things, why is a best practice a best practice? If you understand that, and you come across a situation where I can't do this, it doesn't fit for these reasons. Okay, cool. Now you've eliminated all these other things because you tried things that were best practices. Maybe you are creating a new best practice that's going to be a slight variation on this. But if you don't understand those things, you're going to you're going to have some challenges, and you need to understand why people called them best practices for what they were doing. And if you don't do that, you're going to run into more challenges. I'm rambling. Sorry. Go ahead.
Yeah, no, not at all. Yeah, and we're obviously talking about the first principles and stuff, but how has this changed over the course of your career? Like, are there best practices that were best practices that aren't best practices anymore? And sort of like, how have roles changed?
That's interesting because there is, trying to figure out ways to put this. There's a diminished emphasis on things associated with data modeling today, and that's unfortunate. And the reason I say that's unfortunate is because if you take a little bit of time, as I say, and design some good data structures, you can design some things that are used for multiple use cases, not just your immediate use case. And because of that, we end up building a lot of throwaway stuff.
Yep.
And I'm saying we as an industry. And yes, there's a time and a place for prototyping. We can have all kinds of interesting conversations. However, some of the things that I have done early in my career when it comes to design work and building out a decent design of a data model, and then going to business folks and going to application developers and on, and finding that happy medium that allows business people to understand what is the data structures working, and having the application developers know, okay, this is what's working. This is great. Having something like that, having an artifact like an entity relationship diagram, which I know A lot of people poo-poo those things, but I'm a big fan of them. If you have a well-done ERD, entity relationship diagram, it's useful for more than just one person, more than just one team. And those things become, they can grow, they can evolve, and also they can be studied. And the study part is what I write about, because I've written about in both of us. Actually, we talk about how an entity relationship diagram is actually what's called a graph in graph theory. So from a mathematical perspective, now you have a mathematical object, which is a graph, and because it's a mathematical object, you can study that. And the studies that you can do, you can learn about performance of how things are going to work before you implement it, because now you have a mathematical model, not just a data model. A mathematical model of how data is um, stored and organized. And so I talk a lot about that. I really get into data structure synthesis, where I talk about graph theory, category theory, and some of these other set theory and on. But by having this thing, this ERD, that becomes something that you can have a really intelligent conversation with people. Because even though it sounds like it's really conceptual or complicated or really things, it's not. You explain to somebody, this is what a dot represents, this is what a line represents. Okay, now this is where we store this is where okay, now we've spent 30 seconds to explain what an ERD is. Now, how is this related to that? Oh, well, those two aren't related at all. Okay, remove the line. Oh, that changes how we store data. That changes how we access it. That changes how we query it. Oh, there's no longer a need for this. There's no longer a need for that. And now you're storing less data because you're doing it more efficiently by understanding the use cases. And you're saving money. You're increasing value. All of these things. That artifact, to me, is that's one of the things that I don't see enough of today. Mm-hmm. So if you say what is missing today that used to be around, data modeling as a practice, data modeling as data modelers having a seat at the table from an architectural perspective of how things are built, that to me is missing.
Yeah, so that's really interesting. So you were talking about things being set up to be throwaway. And certainly when I do a personal project or something, I, have made the mistake multiple times and had to shoot myself in the foot because I don't set things up well. But of course, it's way more important in an organization. So from your opinion, and you had mentioned that there was like a lack of data modelers, like do data engineers they're supposed to be able to data model, right? I guess what I'm getting at is, what do you believe, from your opinion, is the reason why things might not be set up in the best possible way to begin with, whether it's, change in personalities, not as much access to expertise, the roles that we have, trying to perform this function? Like, what do you think is the difference?
There's how much time do we have left? Almost all of the above is the answer. Some of it is expertise. I've met plenty of people that think they know how to data model that don't. I mean, there's just no nice way to put it. You just don't know what the blazes you're talking about. Some of it is the perception that it takes to present value. Part of the problem with that is that it adds value on, right? It's very easy to do something quick and done, like you said. Prototyping, here we go. We have something. Cool. Doesn't scale. It's not reusable. You have to build 80% of the same thing for this other thing 2 months down the road.
Yep.
So one of the I think it's, those of us that have done plenty of data modeling, obviously we've got our own expertise. One of the challenges we have is communicating the value that and the value that it represents for being able to save time, make things more efficient, on and on. So some of it is expertise, and some of it is simply communication, because if you take a little bit of time, build a decent data model. That doesn't mean that you're stuck with that forever, but you have to have something to start with, right?
Mm-hmm.
And so having a data model, being able to audit that, make sure it's usable for all of the right use cases, on and on, it has a high degree of value that unfortunately is just not, it's not presented as a valuable artifact.
Nope, I just thought of a story that completely aligns with that because when,
Please.
I was working at a company and it was a subscription product. And so, of course, they were very interested in being able to analyze churn. And well, however the data was structured, we weren't able to get at that accurately. And it wasn't until the stakeholders were really upset that they couldn't actually get to the numbers that they had, their quarterly goals were tied to this thing that was not accurate, that they did not have access to, no matter how we tried to, massage or whatever as an end user data scientist, it was not going to get there. And it wasn't until the business really said, okay, we need to raise this up. And it was actually the only time that I've been involved in a data modeling project because I was so familiar with this subscription data. But yeah, no, I've seen it. It's like you work with data and it's broken and it just lives broken for a long time until like the squeaky wheel, often because is like the business is feeling pain,
Mhm.
that they make a
Right.
difference. It wasn't data scientists, saying that there's pain. It had to be the business saying that there was pain.
Absolutely. Yeah. I've seen, I could tell some more stories.
Yeah. Okay. So, are there any misconceptions that you can share about data enrichment or, data data structure synthesis?
I think the biggest thing is what I just talked about, is the perception of value for doing that.
Perception of value.
Um, and it's difficult because you're communicating with, um, what we build is all virtual, and people are, oh, we just make changes and move on. Well, okay, but because you're dealing with certain volumes of data and this and that, if you don't organize it the right, then it's going to make it more challenging. For those of you that do frequent libraries, not that that's a big deal anymore, but for those of you that do frequent libraries, if you went into a library, here I am in Northern Kentucky. If I go into a library here, and then I go into the New York Public Library, if they had completely different ways of how their books are, how would I find anything? I
Mhm.
wouldn't. I would be lost, and the New York Public Library is huge. um, but we have this thing called the Dewey Decimal System, right? And there's a reason why we organize books the way that we do it. And so you walk into a library, you're like, da, 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 okay, I know I need to go compared to the 900, go through this, and that kind of stuff. So we have this semantic layer that is above the data, which are all the books. And because we have this semantic layer, regardless of where we go, we know how to find what we're looking for, right? So this an ERD in a lot of ways is the semantic layer of how the data is, and that becomes how you can then, oh, okay, well, I need to select this data and that data, join here, do this. Now I've got my numbers for being able to do this. Well, I need to take this data and this data over here and combine it, but I know that that is going to be related to these other things that will produce these other data products. So now I have two data products that are originating from slightly different structures, but ultimately they can be related because they came through this process of using these data structures.
That's awesome. And we are going to hop over into Q&A. Okay, so Benjamin has asked, what general advice do you have for organizations struggling with outdated or inefficient data structures?
One, go buy the book Data Structure Synthesis and read it, and then you can apply the principles that I've learned that. So when you talk about inefficient data structures, really it's, why is it inefficient? Define inefficient. What is it? What are you trying to accomplish? And so part of the thing, and the reason I'm yes, obviously I'm trying to sell books, And so that's a little bit of a snarky answer, but there are mathematical tools that I write about it for understanding why a data structure may or may not be efficient. And part of that is um, just to get into the math. Essentially, what I'm doing is I show people how to do a proper profile of the data and look at what is looking at column by column. How are the columns changing related to the entire row? Okay. There's a mathematical thing in there that an expression that I put together that explains all of this kind of stuff. And so then you take that information and you do some cluster analysis. Big on my data scientist. And so what you have then is, let's say you have a 40 column wide table, but the rows are the rates of change are different, really in three different clusters of data. You know, 15, a 5, and a well, that's 30. So anyway, you have a 30 column line. So you have really three different clusters of rates of change of the data profile. And you can see them. Okay, so really what I have then are three different categories of data. So this is where category theory comes into play, where I'm going to break that apart and make it a little bit easier to organize. And by doing that, each of these individual things with different rates of change then can be made more efficient because they would be smaller. Think of that as, think of your address data. How often does city, state, zip change? Well, it doesn't. So have that on a lookup table, right? Um, whereas other things, name, where you can change your name all the time, whatever. So name is going to be changing less frequently than state. So just by looking at that and profiling those numbers, doing the proper profile of the data, you can identify how to make your data structures more efficient.
So were you saying that those three categories, that each of those should become their own table instead? Or,
Sure.
Yep, okay.
Potentially.
Here is a question from, I don't want to pronounce your name wrong. How do you ensure enrichment respects data privacy laws like GDPR or CCPA?
Why do we want to respect any laws? Why are we worried about that? No. The
The law.
fact that you're asking the question, um, that alone helps you answer it because you've identified potential things here. Now you have data that does need to comply, that needs to be GDPR compliant, versus data that does not. And then how do you put that together? You may want to join that data, obviously, but that would be through like a soft join or a view or something like that, some other mechanism. But there are physical storage requirements associated with GDPR that gets into regions and all kinds of craziness that I don't want to talk about in this setting. There are rules associated with GDPR that data has to be compliant. Okay, so if you put that data together in the manner that is GDPR compliant and make it relatable to other data that is not GDPR compliant, then you're able to do better enrichment, right? So the data that is not required to be GDPR compliant, you have to do less stuff with it, right? You have to do less masking and all the other things associated. Whereas the GDPR data, because you have that isolated regions or what have you, it's able to comply with all of the rules that are necessary for you to comply with. But then you're just using things like soft keys, foreign keys, to relate the two things. So that would be an approach. Keep your GDPR data where it needs to be GDPR compliant. Make sure that can be related to the data that is not, and then you don't move the GDPR data from, you don't break any GDPR rules. But by making it relatable, you're able to better enrich it and still be compliant.
Okay, and do you find that, because of course you can enrich data in multiple ways other than just buying data, but when you buy data from a third-party vendor, like I know that, they won't give you credit card score, but they'll give you something that's called something else that sort of backdoor tells you what bucket somebody might be in. Do you find that third-party data is generally going to be information that is safe for people to use? Or do they need to be careful of that too?
Well, you always need to be careful. You always need to be careful of whenever you're buying data. Period. I'll say that you need to do a bit of due diligence. That being said, some vendors are more reliable than others.
Okay.
And so to your point about credit card data, frankly, I've worked with Experian and TransUnion data in the past, and what we were doing was we were pulling in this enriched data from Experian and TransUnion. We were making it, organizing it, so we had to do a lot of data munging and ETL processes to get it to work, and then that would go into statistical models for our marketing department to do research on,
Yep.
and ultimately target particular sets of demographics for customers. That third party data was incredibly valuable to us because we paid a lot of money for it. And so it wasn't just that wasn't the only reason, but it was valuable because of what it represented. Again, going back to the whole thing, people. When you're dealing with credit card data, Experian data, that kind of stuff, you're truly that is that is your demographic information. That is each of those records is a person.
Awesome. Thank you for that. This question is from Charles. How do you balance the difficulty of enforcing standards and quality in your data models without slowing down business processes?
Who sets the time for your business process? Usually, it's your business owner, which are saying, I need this tomorrow. That's where you need somebody that has executive support that can go, stop. No, you don't. You're not getting this tomorrow. It's not going to happen for these reasons. What do you really need? When do you really need it? Let's have a conversation now to figure out how to make this, how to build this the right way to support the enterprise as a whole, as well as meet your individual little needs. That's where it takes strong leadership when it comes to these kinds of things. And unfortunately, I've seen that very rare. Because you're like you were talking about from your business folks, they tend to be very pushy. Well, one of the things you need to ask, and I've done this before. I mean, I've had conversations with CEOs and C-level people. They're like, I need this tomorrow. Really? This is what it's going to take for you to have that tomorrow. Is that the price you're willing to pay? Oh, when can I have it? If you let me do it the right way, you can have it here. Okay, that fits in with what I need. Thank you. And it ends up being a positive thing. But if you just take, oh yes sir, I'm going to go run away and do this right away and burn out all my people, you're going to use up your resources, and you're constantly going to be on a treadmill. So you need to have some conversations, and you can do things efficiently without slowing things down. But you need to make sure part of it is education. So long as they understand these are the things that we need to do in order to meet your goals. We can do a shortcut, fine, but ultimately you're incurring what is today called technical debt that is going to require us to rebuild this later for whatever reason, or these other things. And usually when you start talking about dollars and the cost of storage, and oh yeah, we're going to charge this back to your business unit. So if you want us to do something inefficiently, that's fine. I've got a chargeback model that means your bill is going to go up because you want me to do something different from what everybody else is doing. If you have that chargeback model, suddenly you're having a different conversation about slowing down businesses, because now they are realizing the cost that they are incurring to the overall enterprise. If you don't have those financial conversations, and it just becomes this wish list of, well, we want to do it the right way. Well, what is the right? Well, I don't care what the right way is. I just need this done tomorrow. Okay, you want it done tomorrow. This is what it's going to cost you. You have to have an accountability associated with that back to the business. And I know chargeback may not be a big deal for certain sizes of organizations, but if you just dump everything into the cloud, you have this big cloud bill that's never associated with individual requests coming from individual business units, then your overall financials for your IT department are bad.
Mm-hmm.
You need to have somebody that has that financial hat within the IT organization that goes, this guy over here is running up costs. This group of people over here, because of their requests constantly coming in, constant changes, constant this, constant the other thing, that bill needs to go to. If that's the way they want to do business, that's fine. We're going to charge them to support that. And then suddenly, when you do that, oh wait, I don't need that tomorrow. The
Yeah.
conversation changes, and it's all about accountability. And if you don't have that accountability, and IT is just your working, it's going to that's going to way it's going to continue.
Awesome. And so, what are the major challenges you've seen with data enrichment? And so, I'd love to hear too from the perspective of, like actually being able to use the data, and then from being able to, actually get it stood up for people to be able to use.
So I'm trying to think of funny stories that I can say. uh, one of the funniest was we had this large volume of data that we needed to do some analysis on before we could do some other stuff, and we had a project manager that was like, and I mean we're talking terabytes here. We did not have the infrastructure easily to get the data, so there was multiple steps. Right?
Did you pay for terabytes to be able to do that join? Okay, fascinating. Continue.
Yeah, we paid for this data, and I was like, okay, well it's going to take this amount of time to load the data here, and then once we had this staging area, then we can do all these other things. The project manager was like, well, can't you make any decisions about the data before you load it? No, that's not how that works. You can't. Yeah, I mean, that's just, I would be guessing. And if you want me as a data scientist to make an intelligent, give you intelligent feedback, and now you're telling me, oh, we'll just guess based on whatever. Okay. That's a major challenge, because if you're not using good tools to be able to ingest data and get to where it's easily able to do these things quickly, it takes time. These are some of these are sequential things that it takes time to do this. I have to go get the data, I have to put it here, I have to do these things, organize it, and oh, by the way, once I have this third-party data, now I've got to combine it with the data. Time is a limiting factor. If you've ever heard or heard of, man, I can't think of her name. Anyway, there was the lady that invented the churn clock. She had a copper wire about this big, and she goes, "This is a nanometer. This is the amount of time light travels in a nanometer. So this is a physical constraint. I can't beat this. Nobody can." And so she was in the Navy. Grace Hopper. It took me a minute to get her name. Admiral Hopper. People were like, "Well, I need this data tomorrow." This is what it takes. So the satellite is that high up. This is how far the data's got to go, and it's going to come back down. I can't beat the physics. Doesn't change. And she had her little nanometer, and she'd go around beating people with it. That whole thing that she came up with, physics doesn't change. I don't care where it's at. If I've got multiple terabytes of data, I was working on one project where literally we were planning out petabytes. So we were planning out the infrastructure to deal with petabytes. You're dealing with the laws of physics at that point. That can become a challenge, where you really need to make sure that you're putting things together the right way the first time, because you're not moving petabytes of data, not easily, and not tomorrow. It's not going to happen. And as the world continues to create more data, we're in exabyte space. What's the next one after that? I forget forget after exabyte.
Oh, I don't know.
But yeah, we're I'm sure there are places that are doing post exabyte data processing. That's going to take time. And I don't care what your methodology is. I don't care what your project manager says. There are things that have to happen in a particular order in order to be able to get the answer. That's all there is to it. That's a big challenge.
Yeah, no. It takes time. It just takes time. It just doesn't get done by the time that people want it. It just doesn't.
Yeah.
All right. So we have time for one more question. This is from Jade. Can you just talk a little bit about the tools that you use, or tools that are maybe your favorite in the stack?
Data Ops Lab, the company that I work for, We have a suite of tools for managing Snowflake. It is Snowflake specific, so that's the only caveat I'll say there. Things like dbeaver, dbt. From a data modeling perspective, I like SQL DBM. Vertibello is another online tool for data modeling. Those are kind of the more frequent, more current capabilities for things. Being able to reverse engineer some of your existing data structures or point at a set of CSV, create data structures from there. Those are really powerful things. Again, Vertibello, SQL DBM for data modeling, dbt for overall data transformation. If you're Snowflake, DataOps Live, those are kind of the tools that I would say that are going to be the big deals.
Awesome. Thank you. So that is all the time we have. So I apologize to everyone who asked questions that I didn't get to. I really appreciate your questions. Thank you so much, Doug. Thank you, everyone,
Thank you for having me.
Thank you. And hopefully we'll see you next week.
Take care.